Introduction. Click on the shutter of the camera to take a photo. What do you notice? Answer. The flash contains a capacitor which takes a few moments to charge up before it is ready to discharge and produce a flash. Capacitors are used in many devices to store charges. Introduction. In this lesson, you should be able to describe qualitatively the mechanism of charging a parallel plate capacitor. Describe the variations of charge, potential difference, and current with time for charging process. Describe the variations of charge, potential difference, and current with time for discharging process. Understand lightning as a discharging process. Click on the switch to complete the circuit and observe the flow of electrons. When the capacitor is connected across a voltage source, such as a battery, the electrons are forced onto one plate, resulting in a negatively charged plate. The electrons on the other plate are pulled off by the battery, resulting in a positively charged plate. Click the Reset button, then the Zoom In button. Close the switch again, and this time observe what happens to the electrons on the plates of the capacitor. When the switch is closed, there is a momentary surge of electrons through the wire to the left plate of the capacitor. This is because the battery is pushing electrons away from its negative terminal. At the same time, free electrons from the right plate are pulled by the positive terminal of the battery. This leaves a net positive charge on the right plate. As the number of electrons builds up on the left plate, it becomes more negatively charged, and electrons flowing towards it are repelled. This reduces the flow of electrons. Eventually, the potential difference built up from the charged plates will balance the EMF of the battery, and charge will stop flowing in the circuit. At this stage, we can say the capacitor is fully charged. Click the switch to complete the circuit and charge up the capacitor. What do you notice about the voltage across the capacitor? Answer. The voltage is momentarily zero. What do you notice about the reading on the ammeter? Answer. The reading of the ammeter momentarily is maximum. Click the Next button to observe Stage 2 and note the readings on both the ammeter and voltmeter. What do you notice about the voltmeter and ammeter readings? Answer. The voltmeter reading has increased, but the ammeter reading has decreased. Click the Next button to observe Stage 3 and note the readings on both the ammeter and voltmeter. Here, the voltage has increased further and the current continues to decrease. Charging continues. Click the Next button to observe Stage 4 and note the readings on both the ammeter and voltmeter. When the capacitor is fully charged, the voltage across the capacitor's plates is equal to 6 volt. This is the EMF of the battery. When they are both equal, their effects cancel out and the current stops flowing. In order to observe a continuous process of charging a capacitor, click the reset button and then click on the switch. Summary. When a capacitor is charged using a battery, here's what happens. The plate on the capacitor that is connected to the negative terminal of the battery accepts electrons from the battery and becomes negative. The plate on the capacitor that is connected to the positive terminal of the battery loses electrons and becomes positive. Once the capacitor is charged, it has the same potential difference as the battery. In this section, we are going to investigate the charging process of a capacitor in a circuit with a resistor. Click the switch to observe how the voltage across the capacitor Vc and the voltage across the resistor Vr vary with time. As the voltage across the resistor decreases, the voltage across the capacitor increases. When the capacitor is fully charged, the voltage across its plates is equal to E. Select the charge time graph from the pull-down menu. Click on the switch. Here, we can see how the charge on the capacitor increases with time. Select the current time graph from the pull-down menu. Click on the switch. Here, we can see how the current in the circuit varies with time. When is the current maximum? Answer: the current is maximum the moment the switch is closed. In this section, we will derive the equations that describe the charging process. The EMF of the battery is equal to the sum of the voltages across the resistor and capacitor. Click the Next button. Here, we are deriving an expression for the charge stored in the capacitor during the charging process. Click on the step boxes to view each stage of the derivation. The quantity Rc in the expression is called the time constant, tau, of the circuit. It represents the time for the charge to increase to 1 minus 1 over E of its final value. At the end of the charging process, what is the maximum charge on the capacitor? Answer: maximum Q0 equals CE. Describe how the charge varies with time. Answer: exponential growth. Click the Next button to derive the expression for current I as a function of time t. Click on the step boxes to view each stage of the derivation. The graph of current versus time for an RC circuit shows that the current changes exponentially with time. The current has its maximum value, I0 equals E over R at t equals 0 and decays to 0 exponentially as t approaches infinity. What is the current after a time of tau? 2 tau. Click on the answer button. Click the next button to derive the expression for potential difference V across the capacitor as a function of time t. The potential difference supplied by the battery E equals to the sum of the potential difference across resistor VR and the potential difference across the capacitor V. Click the step boxes to derive the expression for the potential difference across the capacitor with time. The graph of potential difference V versus time shows that the potential difference V across the capacitor increases exponentially until it equals the EMF E of the battery. When the potential difference across the capacitor equals E, the current stops flowing. What is the potential difference V across the capacitor at time? T equals 0. T equals infinity. T equals tau. Click the answer button. Drag and drop to match the y-axis. Summary.